the record. Yep. Once again, very good morning and thanks for joining everyone. In continues to yesterday's session, so we are going to discuss a first concept, I think, but SQL Server Architecture. So, as a database administrator, uh, everyone must and should know about how that engine is processing in the background, not in the front end. Okay, in the background, but because majority of the time you will sit in the front end. Okay, so what is happening in the background is very important. So we are going to discuss that concept. So how our engine is processing our data whenever we are requesting anything, either we are modifying the data or we are trying to read the data, how internally SQL Server processing. That's one of the first thing as a DBA must and should know. Then slowly we'll go into the we as I told you, we are starting the technical stuff. So slowly you can understand how engine is processing in next 2 to 3 days, because there are a lot of dependencies next to 2 to 3 sessions. There are a lot of dependencies. So some people can understand right away today itself. Some people can't understand today. You need to hold 1 or 2 days so that you will get clarified how entire the data is processing in the background. Whenever I'm loading the data, Subbu, when I'm reading the data, how engine is working. That's what our main focus. So before we start, okay, yeah, Harsh, you are asking a doubt. Yeah, you can.
My question is during our performance tuning classes, do we cover weight types? Are they very important, or do
Weight
we?
types are more powerful, sir. Okay. Weight types, update statistics, DMVs, DPCC commands. Okay. These are more
Mhm.
powerful. We must and should have it, because see why your thread. So technically we'll call it as a threads. Why your thread is waiting, for what it is waiting. If you get the weight type, then how you will treat that weight. Okay, why that weight is occurring, how to avoid that weight in the future, how to avoid that weight in the current. So definitely we should know how to troubleshoot the weights. Almost we are having 1,000 plus weights are there. So almost we are having that many weights. Will we discussing all the weights? No, top 10 to 15 weights we will discuss. Top 10 to 15 weights in and out we'll discuss, because how, like a CX packet, CX consumer, and async network IO, SOS scheduler yield, page latches, page IO latches, writer log, thread pools, HATR sync weight. So each and every weight having unique troubleshooting. We need to understand about the weight functionality, and we need to understand how to avoid that weight so that our SQL Server can give the best performance. Mandatory, we must and should know, sir. Yep. Without weights, I can't complete the performance tuning. Weights are so important. Before we go into tuning itself, we'll start the weights. Weights are very
Okay.
important. Statistics are very important. Performance counters are very important. DMVs are very important. Indexes are very important. All these are very important. Then only you will start going for tuning. So whenever you are working on the performance, so based on the weights, based on the indexes, based on the statistics, you will get some idea. Okay, maybe my stats are up to date, my stats are not up to date, my indexes are not using by my query. Oh, some excessive amount of uh, RAM, or excessive amount of CPU, IO. So by seeing the weights only, you will get to know a little better understanding.
Got it. Thank you.
Yeah. Any questions? Anyone? Okay. Anyhow, we haven't discussed too much technical last two sessions. Okay, 3 sessions. Just only the process. So today we are going to start. Okay. So the main concept, that is nothing but SQL Server Architecture. See, SQL is a language. Okay, SQL is a language. Okay, so don't get confused. SQL is a language. Like you already know about C, C++, Java, Python, .NET. Okay, PySpark, Gusto. These are all the languages. Along with SQL is also one language, a common language for entire your database management system. Whenever you go for Oracle or Postgres or MongoDB or Redis or or Terraform or Sybase or SQL Server or DB2, okay. So we will use a common language that is nothing but a SQL. SQL is one of the language like C, C++, but it is not that much complicated when you compare with the C, C++, Java, Python. SQL is not that much complex language. Okay, so SQL is a language, so don't get confused. But now what we are learning, Microsoft SQL Server, okay, is our DB engine, is our Microsoft database engine where you are going to store your data. See, data is very, very important. As a DBA, data is very, very important, sir. So what do you mean by data? That can be movable data, that can be non-movable data. Somehow you need to store somewhere for your future reference purpose or current. Okay, somewhere you are storing. So see, basically we are a back-end people, not a front-end people. See, whatever you are seeing is a front-end. So for example, majority of the people knows about Amazon. I'm just taking example of Amazon, sir. So whenever you open Amazon.com, what you will do, you will try to log in. You will provide your username, first name, last name, your email address, your mobile number, your passwords. Okay, and you will try to register into the Amazon.com Amazon.in or Amazon.com. Okay, you will try to log in. Now, you book your order or you just verify the product, any discounts or everything, and you just log out and you just went for the day. And tomorrow also you back and you are trying to log in. See, whenever you are login, where your data is storing, this is your front end, sir. This is complete. Whatever you are seeing is a front end. Whatever you are seeing is a front end. Somewhere your data is storing, right? Somewhere your data is storing. Okay, your first name, last name, middle name, okay, and your email address, your mobile number, your passwords. Somewhere it need to be stored along with not only your details, okay, along with what products you are ordering, okay, whether it get delivered or cancelled or rejected, okay, and your shipment details, who shipped, when it got shipped, when it got delivered, when you got booked. Somewhere it is tracking, right? It should track. And once you book the order, you will go to your orders and you can track your order information. And if you wanted to see your order, where it is the current state, whether it has been packed or not, whether it has been shipped or not, whether it when it is going to deliver, somewhere you are tracking the information, somewhere you are ordering the information. You are ordering and you are tracking. Ordering is nothing but loading the data. You are loading the data and you are reading the data. Majority of the time, this is the two things we'll do. So we are not front end, we are back end people. So back end. So somewhere this information, somewhere we are tracking. So what orders you are placing everywhere, everything like this Amazon. Just I'm giving examples, sir. If you go to the banking sector, okay, if you go to the banking, so it contains lots of information and lots of policies. Okay, so if you go to the banking, there are lots of insurance, lots of policies, lots of loan details. There are lots of applications out there. Okay, so where they used to track much more things. So whatever the front end you are seeing, back end is very important. We are a back end people, not a front end people. So back end, somehow our data is storing. Whatever you are doing in the front end, somewhere your data is storing. So where your data is storing, either it can be Oracle, or it can be SQL Server, or it can be Postgres, or it can be MongoDB, or it can be Sybase, DB2, Teradata. Lot of DB engines are there. Somewhere our data is storing. So which technology we are using, okay, to store our data? Some people will use Oracle, some people will use SQL, some people will use Postgres. Somehow our data is storing in our databases. In case if something happened to our services, our SQL services, something happened to our SQL services, entire that application will goes down. Entire that application will goes down. Like for example, this application won't works. this application won't works. This application won't works because your application is mapping to the backend database, right? If database services went down, this application will also won't work. So majority of the time, okay, our DB engines will plays a major role. So we are storing data. So please be careful. That's a very important. We are storing our data. What data? It can be any data, sir. You are storing a data. It can be banking, insurance, government sectors, okay, manufacturing, telecoms. Okay, it can be any data we are storing. So majority of the time, okay, like Domino's Pizza, okay, earlier my project is Domino's Pizza. We used to store the Domino's Pizza details and everything, and I used to store for when I work in telecom. Also, I got chance to work. So Idea in India, everyone can understand. Idea is a telecom SIM. Okay, where we used to store the details. So your data somewhere it is storing. So that data only we are protecting. So we need to be little so careful. We should be so careful because we are dealing with the data. If something happened, we are gone. Take a banking, sir. Okay, banking, very critical applications. Banking sector is very critical. At least in the span of your entire DBA career, at least in the span of entire your DBA career, at least we need to work once in a project in the banking sector, so that you will see the how the security firewalls they will set it, massive firewalls, government sectors and banking sector, insurance sectors, they will secure the firewalls massively. They need to protect their data because they are performing a massive transactions and very critical. All are critical. So, what kind of project you are working? Until at least no one knows, sir. Okay, until you got selected so and so company and so and so project, they will let you know what sort of project it is, what sort of information you are storing. See, we don't have any dedicated projects, sir. Basically, means uh, like a Java people or .NET people, what they are doing actually, Java people. So this is one work. Okay, they will allocate a Java developer. Hey, can you design the home page? My homepage need to looks like this. My logo, my personal, my NRS, my business, my IC, iShop, resources about help, complaints, and number. My homepage need to look like this. Now again they will allocate one more developer. Okay, when I just click on personal, it should be visible like this. Deposit, payment, cards, loan, investment. That one more developer will start designing, like one more Java developer they will allocate for to build the page. So they are going to build the pages, and finally they will merge everything. Finally they will merge everything. So this is the like a front end people are doing, like they can use the Java, HTML, CSS, or they will use the Angular JC, and they will use the WordPress to build these pages. Okay, and somehow when you go to the deposits, so uh, what kind of deposit you are doing? See, there are lots of pages here, and these pages are mapping in the background somewhere, because every page is mapped to the database engine. Subbu means no, because what sort of data that page is doing, and that page is mapped to which database. Usually we knows everything the Subbu in the real world means no. What we will do, they will request, hey, can you go and create a database, and can you grant the permission? They will create the tables, they will map internally. Extremely we don't know, sir, how this functionality majority of the time, but somehow to understand, that is what I'm saying. Okay, so whenever you are logged into the portal, okay, so these many login pages are there. So when you go to the personal, you will provide your username and password. Now in the background, this page is mapped to so and so database, this page is mapped to so and so table. Now it will go and verify whether this login is available and this password is matching. In case your login or your mobile number, your password is mapped, it will authenticate to the server. It will authenticate to the portal. If not, it will show you a invalid email address, invalid password, invalid mobile number. Okay, login doesn't exist. Okay, so you will get some pop-up kind of stuff, right? So from where you are getting, from the database engine only you are getting. So far we are completely unaware, but that is how the underlying process is happening. Whatever you are doing the front end, back end, somewhere it is storing. Somewhere it is storing. That storing we are doing, sir, basically. So we are dealing with the data. It can be e-commerce data. It can be banking sector. It can be insurance sector. Okay. It can be any insurance sector. It can be banking. It can be telecom, whatever, sir. It can be manufacturing. It can be passports. It can be uh, government sector. Anything. You are storing the data. So to understand, okay, that okay, Subbu, now I understood that okay, one of the application is mapped to so and so SQL Server. Okay, fine. Now before I go into that much technical, you should understand about how my SQL Server is working, functionality. Okay, how my SQL engine is designed. Okay, how my SQL engine is designed. So when you go to the SQL Server architecture diagram, okay, SQL is a language and SQL Server is our engine, sir. Okay, don't get confused. SQL is a language basically. SQL Server is the Microsoft database engine. Microsoft database engine. So when you search for SQL Server architecture diagram, you will find lots of images. Most of the time, very simple and similar kind of stuff. Let's take this one, sir. Okay, and if we go for one more Oracle architecture diagram, okay, you will find a massive and very detailed diagram. Okay, when you especially searching for Oracle uh, architecture diagram, you will find little uh, detailed diagram. So whenever you see this one, you will get, oh my god, this much I need to learn. Okay, how this diagram got designed, whatever we are going to discuss here, same thing here also we are discussing same, because almost all the database engines are working similarly only. Okay, whatever the concepts we are in SQL we are discussing, almost same kind of things we'll discuss in the Oracle also. So the people who are from Oracle background, you will see little more detailed architecture. That is very good thing. We need to appreciate the Oracle people. They are providing a good interactive architecture diagram. Very interactive. You can understand easily. But when you go to the SQL Server, it is not that much clear. Okay, it is like a okay. We need to accept something. Okay, so when we go for forget about Oracle, all the steps, that's what it is. Okay, the people who are from Oracle background, for them I'm showing, okay, whatever the things you are doing on the Oracle, similar things you will do in the SQL also, in the even Postgres also. Majority of the time similar, sir. Okay, only the here and there the terminologies will be changed, but underlying concept is same. Now, okay, so fine. See, when you specially go for SQL Server, okay, first we should understand about how that is designed while you are processing, while in the background. See, not in the front end. See, in the front end, you will open SSMS, SQL Server Management Studio. Okay, it's a tool where you can connect to the SQL Server. Common tool. Majority of the time you will use SSMS. Majority of the time you will use SSMS. Like when you go for Postgres, PZ admin 4. Okay, PZ admin 4. Majority of the people will use the PZ admin 4. Okay, Linux people, they will use the putty. They will use the putty. Some people will call it a putty. Some people will call it a putty. Okay, this is the tool they will use to connect to the Linux servers. So definitely you will find varieties of tools based on your technology. The tools will be differs to connect. See, once you install the SQL Server, our job is done. No, right? You need to connect to the SQL Server. You need to create the databases, tables, granting the permissions. Much more you need to do it, sir. For performing all that action, definitely you need one graphical user interface. Okay, either you will go for command line or you will go for graphical user interface. So majority of the time SQL is completely graphical user interface. interface system. So Microsoft itself provided a tool called SQL Server Management Studio, and you can access the SQL Server and just you can connect to the DB engine, database engine. Our main focus will be the database engine. I told you, right, there are other components also. There are a lot of components also. Our main focus will be the database engine. And now you can connect to the database engine and you can start processing your action of item, why you are connecting to SQL Server. Then you can start it. But first thing, before I connect to the SQL Server, do that one, this one. First, you should understand how this engine is designed in the background. In the background, how this engine is designed. That is what we are discussing today, sir. The first thing we are going to discuss is SQL Server Architecture. SQL Server Architecture. How our architecture is working. So when we specially go to the architecture, there are three layers. There are three layers. Okay. There are three layers. So first layer is a network layer. Okay. First layer is a network layer where we need to focus network level. Okay. First layer is our network layer. Second layer is nothing but our database engine layer. Okay. Third layer is nothing but SQL OS layer. Means SQL is having own its operating system. SQL is owning its own operating system. So there are three different layers. And for example, this is your application, app user. Okay. It can be SSMS. It can be any tool. Okay. It can be SSMS. It can be Amazon.in. It can be any tool. We don't know what application they are using. Okay. Means once you got the project, you will definitely know, sir, what kind of application they are using, how they are connected to the SQL Server. Definitely we know. As of now, it can be application, it can be SSMS, it can be Amazon, it can be website, it can be tools, it can be third-party tools, any tool. Now, when they are trying to connect to the engine, okay, how my request is passing, is very, very important. So first, it will go to the network layer. First, before it go to the once it go to the network layer, there is one more layer called SQL OS. What SQL OS is doing, what network layer is doing, what our DB engine is doing. So as of now, today, we are discussing only these two layers. Okay, in the advanced level, I will talk about SQL OS architecture because it is too much technical. The people who are first time listening, it's very difficult to understand these terminologies. Okay, let's start this architecture in the advanced level. I will come up when we are discussing the CPU troubleshoot. Means while we are discussing, while we are discussing the CPU troubleshoot, okay, first I will talk about the SQL OS architecture, then only I will go for the CPU troubleshoot, sir. Okay, so no worries about that stuff. First, let's focus only these two. Okay, let's focus only these two layers. This layer I will focus mainly on the advanced level. When we go for advanced level, so we'll mainly focus on how this SQL OS architecture is working. Now, first, okay, is it clear, everyone? What we are learning? How my engine is working means whenever user is trying to connect to the SQL, see, it can be either you, either apps team, either developers, either testers, or someone, sir. When they are trying to connect to the SQL server, how my queries are processing means, so technically you will call it as a queries in entire our database engines. Okay, you will call it as a queries means you can perform select statement, you can perform insert, you can perform update, you can perform delete. Majority of the time you will do this one or create. Majority of the time you will do same things. Select is nothing but reading the data like electricity bill, water bill, telephone bill, or credit card bill. Okay, then technically we'll call it as a select statement. We are trying to retrieve the data. Insert means we are loading the data. The new record. The new record means whenever you go to the bank and you wanted to open your account, they will insert your data. And after loading the data, you wanted to update the data, you wanted to update your email address or mobile number or first name or last name, then they will update the data. And if you wanted to close your account, they can delete the data. Okay. If they wanted to create the structure, so create is nothing but structure. If they wanted to create a structure, then they will go for the create. Based on the requirement, they will create the structure first. Once they create the structure can be anything, sir. Tables, views, okay, views, stored procs, SPs, functions, functions. It can be anything. Okay, therefore it can be functions, stored procs, views, tables, sequences, indexes. They will create the structures, and based on the structures, it will work as a functionality. We'll talk when we are having a development session. One day we'll talk about what developers are doing. That time you can understand, sir. Okay. Now, when you are performing any one of this, how my engine is working in the background, not in the front end. See, in the front end, what you will see, I will go to the specific database and I can read the data. Select, okay, for example, select, come on here, select the sales dot sales order details. For example, I'm going for this select statement. I got the data. Okay, I am just able to read the data. Like same, I can insert the data, update the data, delete the data, create the structure. I can do much more things. These are all falls under SQL queries. Whatever you are doing here, like a select, insert, update, delete, create, drop, truncate, whatever you are doing, all are SQL language. You are doing the using SQL language. You are going to processing your data, rendering your data, whatever you are doing with the SQL language. Entire our DP engines are working with the a SQL language like a C, C++, Java. In the front end is very easy, sir. I just perform a select statement. I am reading the data. I just perform a select statement. I got the data. Okay, fine. But when you are sending this request to the engine, how my engine is accepting your request, how my engine is processing your request, from where I'm getting the data, how I'm getting the data, that is what you should understand. To understand that one, you must and should know about the SQL Server architecture. You must and should know about the SQL Server architecture. Is it clear, everyone? No. Yes.
Yes, sir.
Yes, sir.
Yes. See, basically, SQL Server will follow client server architecture. Okay, there will be client, there will be server. Okay, client, server, server. Only two-tier. Technically, we'll call it as a two-tier architecture. Like if you go for, I'm not sure how many people knows about Oracle apps, ERP tools like SAP, Oracle apps. These are the ERP tools. When you go for Oracle apps, this is a three-tier architecture. It's a three-tier client, server, and middleware. Middleware. Like a Java. For Oracle apps, definitely you need a Java. You need to install the Java, and you need Oracle, and you need Oracle apps tool app like a client. Okay, so there is a middleware kind of. It is a three-tier architecture. But our SQL, our mostly database engines like Oracle, Postgres, or SQL Server or MongoDB, all will falls the two-tier architecture. We don't have any middleware kinds of. Means if I want to connect to the SQL Server, I need something. No. Okay, there is nothing called middleware. It's a completely two-tier architecture. So if someone is asking, hey, can you definitely there is a question, sir. Can you please brief about SQL Server architecture? Even you are having massive experience also. Some people will get this question, a common question called, can you please brief about SQL Server architecture? Definitely will get this question, sir. Now, to answer that question, to understand the flow, we must also know about the architectures. So we are having a lot of architecture in SQL Server, like SQL Server architecture, okay, storage architecture, okay, log file architecture, TabDB architecture, memory architecture, okay. So we must and should know these many architectures. So slowly we'll talk about this high level, but as of now we'll focus on these two: SQL Server Architecture and Storage Architecture. Okay, SQL Server Architecture and Storage Architecture we'll talk. Rest things we'll talk in the advanced level, like log file, TempDB, memory. We'll talk in advanced level. First, let's focus on the SQL Server Architecture and Storage Architecture. We'll talk rest of the things in the advanced level when we are talking performance tuning. So, first thing, if before you explain to someone, okay, first, SQL Server is the Microsoft RDBMS technology, Relational Database Management System. Okay, tomorrow we'll talk what is DBMS, what is RDBMS. We'll talk some internals. Will I need to know Subbu means? Yes, sir, because you are a database administrator, right? You mustn't should know something related to the RDBMS, DBMS, hierarchical level, okay, network level, hierarchies. You mustn't should know the hierarchical level, what is happening in the background. As of now, we are focusing only SQL Server. SQL Server is a Microsoft RDBMS that works on the client and server architecture. There will be client, there will be server. There is nothing called middleware here. Okay, end user send a request means it can be from SSMS. See, SSMS is also client. Okay, SSMS is also client. Okay, SQL CMD is also client. See, this is the tool. Microsoft provided a tool called SQL CMD. Using SQL CMD also you can connect to the SQL Server. Okay, not only SQL CMD, even Azure Data Studio is also a tool. So we are having lot of tools, sir. Okay, Azure Data Studio, Visual Studio, data tools, SSMS, SQL CMD. These are all different tools while we are authenticating to the SQL. Okay, but majority of the time we will use the SSMS. We will use the SSMS, sir. Developers, apps team, they will use the Visual Studios. They will use the Visual Studios. But majority of the time, DB people will use the SQL Server Management Studio. SQL Server Management Studio. Now, while you are making a request, see, while you are making the request, how my request is processing in the background is very important. See, when you see the front end, it's very simple. Oh, I just connect to the SQL Server. I just connect to the SQL Server. I just perform select star from sales order details, and I receive the data. This is very simple in the front end, but in the background, how it is working. That is what we are learning today, sir. Now, in the background, how it is working means, see, when you install SQL Server, and if you go to the task manager, okay, if you go to the task manager, open the task manager, sir. If you open the task manager, if you go to the details, you will see SQL Server.exe, which is in running state. Okay, this is one process. Like Google Chrome is one process, PowerPoint is one process, Zoom is one process, Edge is one process, SSMS is one process. Like SQL Serve is also one process. Whenever you install any SQL Server and that service is currently running, when you go to the task manager, you will see SQL Server.exe file which is running in the background. If this is not running, you can't authenticate to the engine. Means you can't connect to the engine. If you stop this service, you can't connect to the engine. So if while you wanted to authenticate to the engine, make sure that your SQL Server service should be running properly. If this services goes down, see, if this services goes down or this service, both are same only, sir. Both are same. If this services goes down, okay, entire your engine will be goes down. Knowingly, unknowingly, whenever you are installing any service, any application, in the background, there is a service. There is a service, sir. See, first you should understand the concept. Forget about technical. Either it can be Oracle or Java or for example, antivirus. You are installing antivirus. You are installing Microsoft Office. Okay, you are installing PUBG, you are installing any application over the server. Okay, definitely there will be service. Definitely there will be service. If you stop the service, definitely that application will be goes down. So you need to make sure that you need to run the service continuously. Otherwise, no one can connect to the DB engine. No one can connect to the DB engine. So entire your database engine is relying on this service. Is relying on this service. If this service goes down, entire your database engine goes down. Means you can't connect to the engine. An application can't connect to the engine. Entire application will goes down. So whenever you go to the bank, they will tell server is down, service is down. Okay, that time maybe our SQL is went down. Due to that whatever the application is mapped to that engine is went down. So then how application can run? Maybe sometimes application issue, maybe sometimes DB engine issues. Every time it's a DB engine issue, no, no. Sometimes application issue, sometimes DB engine issue. Imagine if DB engine out, then DBA will come into the picture. So how I can get to know, Subbu, whether my SQL engine is healthy or not? Means make sure that when you open the task manager, okay, SQL Server.exe file will be continuously running. If it is running, okay, my engine is currently in the healthy state only. Means in the running state, sir. Mean to say. Got it, everyone?
Yes, Subbu. Subbu, I have small doubt.
Yeah.
Like at here in SQL Server, DCV, and SQL Server browser is there, right? In default
No,
instance,
no, wait,
if
wait, sir. Don't go that much technical, okay?
okay, okay,
Rightly. We'll go slowly because there is a dedicated. I will talk about the services.
okay,
Okay, that time I will talk more about SQL service browser.
okay, yeah, yeah,
Okay,
sure.
so I hope everyone getting my point. So SQL engine is nothing but okay. Sorry, entire our database engine follows client and server architecture. There will be client. It can be SSMS. It can be website. It can be tool. Where you are sending request to the engine, and engine will respond based on your request. Either you are loading the data, either you are reading the data. See, mostly you will entire global will follow two transactions, right? Loading the data, reading the data, right? So you will load the data. It can be insert or update or delete or create. You are loading and you are reading the data. So based on your transaction, based on your query, SQL Server or Oracle or Postgres or MongoDB, anything will follow the same. Okay, fine, Subbu. Now next thing. First, okay, first. See, this seems very simple process from the front end. See, I will just connect to the SSMS. I can run the query. I can get the data. This is very simple in the front end. But in the background is very, very important, sir. Okay, in the front end, it is very simple. However, there are multiple processes are running in the background to fulfill this request. Whatever the request you send it to the server to get that request fulfillment, SQL Server is processing a lot of process. A lot of things are happening. Okay, fine. Microsoft SQL Server architecture is very complex internals mechanism with the three major components. I told you, right, there are three different layers. One is what's a network layer, one is engine layer, one is SQL OS layer. There are three different layers are there. Based on three different layers, your entire engine is processing. Okay. First we'll talk
Subbu,
about
SQL OS and API both are included, right? In that image.
SQL OS. See, SQL OS is a mains are actually it's a heart.
Okay,
See,
okay,
because who is interacting with your operating system? Engine is not interacting with your operating system, sir. SQL OS is interacting with your operating system. Okay,
okay,
so that's the reason it's a little high level technical. Yeah,
okay,
that is the one reason I'm not talking here, sir. See,
okay, okay,
architecture I can't explain in the day one itself.
okay,
Entire in our training program, architecture is keep on coming. You keep on enhancing, sir, because there are a lot of terminologies where you can't understand in the day one itself. Only
okay,
experienced people they can understand, but the people who are starting the journey, it's very tough to understand. So we'll slowly will digest, sir. But topmost content we will discuss now. Okay,
Okay.
which you are happily to present to your interviewer. Okay, that much we'll talk. But deeply, slowly we'll digest, sir, all the stuff. Now,
Sure, Subbu.
okay. First, assume this is your SQL Server Management Studio. Okay, who try to read the data. See, blindly you should keep in mind. Select statement is nothing but read. Okay, you are reading the data. Select is whenever you see the select statement. Oh, I am getting the information. I am getting some information. What information? Some. It can be employee data, it can be account data, it can be sales data, it can be product data, it can be customer data, it can be manufacturing data. Something you are getting, sir. Select is nothing but reading the data. Select statement is nothing but reading the data. Now, when you requesting to the engine, I need to read some data. I need to read some employee data. Okay, select. Okay, star from EMP where. Okay, where employee name equal to, for example, Anil. For example, sir, Anil. I wanted to read the Anil data. So in this table, you are having billions of records. Okay, billions of records. Out of this, you want to read only Anil's data. Okay. Now, what it will do first, it will connect to the operating system. See, every engine need to connect to the operating system. Without connecting operating system, how it can connect to the engine, sir? First, it will connect to the operating system. Okay, it will go to the operating system via network. Everything is happening in the network. Okay, network only. Network it will connect and see. First layer, I told you right. There is a first layer called protocol layer. First layer called protocol layer. What do you mean this protocol layer means? Okay, see, first via network protocol layer, it is connecting to the SQL in the form of TDS packets. Okay, in the form of TDS, TDS packets. You can call it as a network packets. See, for your understanding, it is a simple select statement. Okay, for your understanding, it is a simple select statement. But backend, what is happening? This treating it as a packets, network packets, it is converting as a packets, and this network packets is transferring to the engine. This network via network packets, it is transferring. What is TDS? Tabular data structure. Tabular data structure packets. It is a network packet, sir. Okay, it is a network package. This is completely designed. Okay, see, tabular data stream packet structure or stream, you can call it. So SQL Server Network Interface is a network protocol layer to connect to the database engine. Whatever the request you are sending, either you are reading the data, writing the data, whatever. So that entire request will make like a packet and connect to the engine and transfer to the engine to connect. So while it is connecting, there are three different protocols. There are three different protocols. Your connection is encrypting. Your connection, enter this select statement is encrypting in the background. It's encrypting in the form of packets, network packets, and going and authenticating to the engine and going and connect to the engine. So while it is connecting to the engine, there are three types of protocols are there. There are three types of protocols. One is shared memory, one is named pipes, one is TCP/IP. Using any one of this protocol, it will try to authenticate to the engine. Using any one of this protocol, it is trying to authenticate to the engine. How it is authenticating? With help of packets, with help of network packets. It is using any one of this protocol and it is trying to authenticate to the engine. See, tabular data stream is an application layer protocol used to transfer the data between database engine and client. How your data is transferring between client to server, server to client, between client to server, server to client means with help of network packets, which are encrypting in the background. Okay, it was initially designed and developed by the Sybase. Entire Microsoft has been designed by the Sybase. So this TDS concept came from the Sybase only. Still, we are using This concept only, sir. Okay, so your connections are so secured, your processing is also so secured. Okay, when once it connect to the operating system, now whatever the request you are sending, that is completely converting to the network packets in the form of TDS, and it is trying to going and connect into the engine. Is it clear? Is it clear, everyone? How that connections are established means with the help of this any one of the protocol. Any one of the protocol. What is shared memory? What is named pipes? What is TCP/IP? I will talk, sir. First, is it clear, everyone? Okay, how this communication is happening between your application to operating system to SQL. So your connections are so secured in the background. So secured in the background. Now, it will use any one of this protocol. Okay, simply you can't directly, okay, it is converting network packets and it's trying to going and connect to a SQL server. No, sir. It will use any one of this protocol. By default, there will be two protocol will be enabled. One is the shared memory, one is the TCP/IP enable. And named pipes are by default, it is in disabled state. A rare case will enable, sir. So I'm not understanding about this, Subbu. For example, this is your server, okay, where you install the DB engine and you are also having SSMS. I told you, right? SSMS is your client. I clearly told you SSMS is your okay. SSMS is your client. Okay, SSMS is your client. Whenever you are in, for example, this is your server name. Dal SQL 45 is my server name. Is my server name. Within the server, I am having engine. Within the server, I am having client. Okay, here engine is there, here client is there. When you open the client and when you are authenticating to the engine, it will use shared memory because you are in the same server. When you are in the same server, your client and engine in the same server, and you are trying to process something, by default, it will use the shared memory protocol. Within the server, if you are authenticating, okay, then by default, in the background, it will use the shared memory protocol. Shared memory protocol. This is the first case. I hope you are getting my point. Which protocol it will use, Subbu? Okay, you are telling that your request is encrypting in the network packets and going and interacting to the SQL server. Before it interact with the SQL server, it should use any one of this protocol. It should use any one of this protocol. Using any one of this protocol only, it is interacting with the SQL server. Which protocol it will use, Subbu? How I will let you know is where you are authenticating. Within the same server, if you are authenticating, then damn sure it will use the shared memory protocol in the background. We don't need to go and check all. It won't display anywhere, sir. Knowingly, we should understand, okay, if my client and my engine are in the same server and trying to authenticate, it will use the shared memory protocol. Got it?
Subbu, can I ask one question here?
Yes.
Subbu, suppose I have disabled my share memory protocol.
I will talk, sir. I will talk. I will talk in a while. That will also I will talk, sir. Okay. I will show you practically also. Okay. Now, second thing, if you wanted to connect remotely, for example, this is my app server. Okay, DAL app. Okay, app 198. This is my application server. This is my SQL server. Here there is a client. Okay, from here to here you are authenticating. From here to here you are authenticating. So definitely it will use the shared memory protocol. Sorry, come on, TCP/IP protocol. If you are connecting SQL server remotely, please make a note on this terminology, remotely. If you are connecting SQL server remotely, it will use the TCP/IP protocol. It won't use the shared memory protocol. Got it? No? Yes. This is the only one thing you need to remember. While you are connecting SQL server remotely, it will use the TCP/IP protocol. Mostly widely used protocol is the TCP/IP only. Majority of the time you will connect SQL server remotely only, sir. You won't connect to the server and connect to the SQL server. Only majority of the time DBAs will connect to the server and they will do their activities. Apps team, developers, end users, customers, they will connect SQL Server remotely only. So if you are making connecting to the SQL Server remotely, definitely TCP/IP protocol will be used in the background. TCP/IP protocol used in the background. If you disable this TCP/IP protocol, you can't connect SQL Server remotely. You can't connect SQL Server remotely. But within the server, you can connect SQL Server because shared memory is working. If you disable shared memory also, enter your SQL Server, you can't connect. Because either any one of the protocol need to be enabled, sir. Either you need to go for shared memory or you need to go for TCP/IP. Any one at least you need to enable. So shared memory enable means you need to connect to the server and you can connect to the engine. If TCP/IP is enabled, you can connect remotely. From anywhere you can connect to the SQL Server. Clear? Not clear. So can I disable the shared memory, Subumis? Yes, you can disable the shared memory because TCP/IP's protocol is enabled. Either you are connecting within the server also, it will use the TCP/IP protocol. Either you are connecting remotely also, it will use the TCP/IP protocol. Either any one of the protocol need to be enabled, sir. Either this, either this. But majority of the time you need to enable TCP/IP protocol because this is a widely used protocol. Majority of the time you will connect remotely only SQL. Apps team, developers, end user, customers, vendors, they will use SQL Server remotely only. So which protocol I need to enable if you wanted to connect to SQL Server remotely? TCP/IP protocol. If you disable that one, you can't connect SQL Server remotely. Means this connection will fail. It will throw the network related error.
Yes, so we
Yep.
here burned out.
Yes. Yeah.
So now I'm logging to my system from the RDP, and same system have a database engine and client like SSMS. So I have connecting to the shared memory. But suppose I have disabled the shared memory, then I connect the TCPI. Okay, TCPI protocol. But I can disable the shared memory or TCPI. Then can I connect from same engine, same
No.
system?
Yeah, either any one of the protocol need to enable, sir. Otherwise, you
No,
can't connect to the SQL. One
suppose
protocol need to be enabled.
named pipe may be
Forget
enabled.
about named pipes. Okay, forget about named pipes. Okay, first focus mainly on the shared memory and TCP. Named pipes are disabled. It's a dead feature.
Okay.
Mostly we won't use it. So you don't need to think about named pipes. Mainly shared memory, TCP/IP. Defaultly it is enabled, sir. You won't touch these two things.
So first request going to the share memory, or then if share not enabled, then go to the TCP/IP.
See, SQL Server is smarter than us. To tell, smarter than us. Okay. How you are authenticating, remotely or locally? If it is locally, it will go for shared memory. If remotely, it will use TCP/IP. SQL is very smarter, sir. We no need to tell to SQL Server like oh, you need to use the shared memory, you need to use the TCP/IP. We know how we are authenticating. SQL Server can very smarter than us. So SQL can understand how you are trying to authenticate to the engine, either remotely or locally. If you're locally, background, it will use the shared memory. If it is remotely, it will use the TCP/IP protocol.
Okay.
You no need to explicitly go and tell to SQL Server anything.
Suppose I'm connecting locally, and locally the server have a share memory disabled. Then it will be using TCP/IP protocol.
Yes. But that is not a best practice.
No, I understand.
Yeah. So I'm telling you understand. I'm just telling that is not a best practice. So that's the reason we'll enable two, sir. Majority not, sir. 100% will tell shared memory TCP/IP is by default enabled. We won't touch these two protocols.
So it can help us, suppose we want to perform some task on our locally, and we don't want during that task or during that activity or other side or outsider application connects our server, so we can easily disable TCP/IP and do our work. Huh?
No, sir, we never disable the TCP/IP. No. No, we won't do like that, sir. We will drop an email to AppStream. Hey, we are doing some maintenance. Don't perform anything. So we'll update to the customers. See, we should not disable. If you are disabling, enabling, you need to reboot the SQL. You need to restart the SQL. Who will provide you downtime, sir? You need downtime. Means you need to restart the SQL. See, these terminologies are very important, sir, when you are working as agents, DBs. Okay? Downtime. You need downtime. If you are changing this one, you need downtime. Who will provide you the downtime, sir? Will I go and talk to my application team? Hey, I am doing certain things. I am disabling this sort of. Then he will tell, who told you to disable this one? Okay. So
No,
that's
it
the
was.
reason.
I was just trying to understand the thing.
That's what I'm saying, sir. Instead of doing this one, you can drop an email, right? See,
uh,
for example, your app stream. I am a DB. What I will do, I will drop an email to entire app stream. Hey, we are doing certain maintenance activity in the server. Okay, we will let you know once it completes. They will let to the customers, everyone. Oh, this time frame to this time frame, there is maintenance happening. No one will try to authenticate to the system, sir, and they won't perform any transactions. Okay. Now, once it is your activity is completed, then you will let you know the customer, hey, our activity is complete. Please test your application. That is how the actions will go, sir. We won't disable these protocols. Anytime, you should not disable these protocols. That is a bad practice.
Got your point.
Yeah. Okay. That is a very bad practice because you need downtime. Means if you are disabling, enabling, you need to restart the SQL. Every time you need to restart the SQL, sir. Will it acceptable? No. We can let them customer knows, right? To don't do anything. We are performing certain maintenance on the system, like a patches. We are doing patching activity. We are upgrading our systems. We are downgrading our systems. We are expanding the storage. We are expanding the storage. We are moving the data from so and so location to so and so location. So we will do many activities, sir, in the real world. That
Yeah,
will
exactly. Like we are performing change activity. Before
yes.
that.
Yeah. Again, good questions, all are. I'm accepting. Don't think anything. I want to raise your questions only. Okay. Very good. Now,
So, one
yes,
basically, maybe I ask one question. How can SQL identify its connection from the remote or its connection from locally my PC?
that's what SQL is very smarter, right? There are
No,
See,
I'm just asking for the
I
curiosity.
am
How can
telling. That's
identify?
what I'm telling. See, it seems very simple from the front end. Okay, it seems very simple from the front end, but back end there are multiple APIs, sir, internally. Okay, there are a lot of DLLs, exe files, APIs. Lot of things are running in the background, nothing but your binary files. Okay, very simple to understand. If you go to the any database engine, okay, there are lots of binaries, exe files which are running in the background to fulfill us. Okay, fulfill us. So SQL is smarter than us. Okay, SQL can understand, sir. Now,
Is there any mechanism or we can identify this will be connection from the locally, this connection from the remote?
Really means yes. There are a lot. There are a lot means if I go for a little deeper, like you should understand the authentications. See, this is just a connection, right? This is just connection. You need to authenticate also, right? See,
Yes.
if you wanted to connect to the SQL server, you need when I'm trying to connect to the SQL server, what are the things I need to get it? One is my SQL server instance name, my SQL server name. One is your username. One is password. So many things are basically okay. There are many things are happening in basically. It will divert our concept. If I go this level, again it go into the security part. So I don't want to go into that much level. Try to understand again. I need to talk
Okay,
about the NTLM authentications, SSL Kerberos authentications. Again, I need to go for SPMs. Okay, too much deeper it will go. So that's the reason I'm not going that much. I told you, right? SQL architecture is not one day training. It's keep on our journey. keep on you are learning, you are enhancing, sir. Finally, you will got an idea. Okay, I hope you got my point, everyone. So
Yes,
I
Subbu.
need to talk much more stuff, much more. Okay, we'll talk in the upcoming classes, because the people who are starting the journey, they will go mad only. Okay, definitely they will go mad, and they will get panic. Oh my god, I'm not interested to learn the SQL completely. Oh my god, this is very tough technology, very lightweight tools, sir. I'm promising you. Okay, but try to understand the hierarchies. Hierarchies. Named pipes. Okay. Uh, we won't use this one widely, sir, but maybe. I'm not saying that you should not get a chance. You may also get a chance. Like 5%, 0.5%, you may get a chance. See, when you go for years ago, okay, your client, okay, there is a client. This is your client, for example, client like Dal, SQL, sorry, not SQL, sorry, app, okay, 198. This is your client server, and this is your DB server, Dal, SQL 45. How these two are interacting means with the LAN cable, okay, with the LAN cables. So we don't know, sir, how that interaction, because I told you, right, data center. I think, okay, data center. I displayed this one, right, everyone? No, yes, data center, a massive data centers. So we don't know how this data center infrastructure has been designed. Okay, application team knows everything. Windows team knows everything. So when your client and server, see, your DB engine technically will call it as a server. Okay, our DB engine will technically call it as a server. When your client and server is interacting via LAN cable, then we will enable the named pipes. Okay, but Microsoft itself recommended, sir, named pipes is not a best practice. Always they need to, because they want to secure the connections. That's the reason we are calling as a TCP/IP is a widely used protocol. Widely used protocol, but named pipes always it will be disabled. Then why Subbu Microsoft can duplicate this feature, right? Means, see, again, that application is having some compatibility with the TCP/IP protocol. That application, this application is incompatible with the TCP/IP protocol or shared memory protocol. Then they will request us. Who will request us? AppStream will request us. Hey, we are authenticating to the SQL Server with the LAN cables, okay? LAN only. So you must and should enable the named pipes. So then only we will enable the named pipes. Otherwise, we never enable the named pipes, sir. Due to application compatibility, if they will requesting us, then only we will enable the named pipes. Otherwise, it will be keep on in the disabled state only. Got it? No? Yes. Everyone, when you will go for named pipes, means when your app server, your client and server is interacting via LAN cables, then we will enable the named pipes protocol. Otherwise, we won't enable the named pipes. Completely will stick with the TCP/IP protocol or shared memory protocol. And there is one more protocol also, sir. It is disabled. It is duplicated, not disabled, duplicated. VIA. VIA. This already duplicated, sir. Virtual interface adapter. Virtual interface adapter, VIA. When you are interacting your client and server via Wi-Fi, okay, I also not work with this protocol. Okay, when I started my journey, it's already duplicated. Okay, no one will ask about this protocol, so I'm just adding a flavor. Okay, so no one is, you never get a chance about this protocol when,
So
as
is it
per when
2012 disable or 2008 R2?
before 2008 8R2 itself it got disabled, sir. Okay, in
Okay.
2005 also it is not available. I'm not recalling.
Okay.
Okay, I'm not recalling which version it got disabled, but it got disabled. So it's already duplicated, not disabled, sir, duplicated. It's already duplicated. Earlier we used to have 4 protocols. Now completely Microsoft came up with the 3 protocols. One is state memory, one is named pipes, one is TCP IP. Okay, these are the only three. But VA is also there. Virtual interface adapter. When your client and server is interacting via Wi-Fi, we used to enable this protocol. So that is no more concept and no more. So only two protocols you need to remember. One is the TCP IP, nothing but remotely. Okay, if you wanted to connect SQL Server remotely, then you must and should enable the TCP IP protocol. If you disable the TCP protocol, you can't connect SQL Server remotely. Got it? No? Yes.
Got it, Subbu.
If you wanted to connect SQL Server locally, then shared memories happily work, sir. Okay, fine. Okay, that's what. Using TDS packets, okay, using any one of the protocol, see, your connection is first going to the SQL, your engine, your database engine, sir. It is connected to the SQL. Okay, whenever you see the externally, it is just your database engine. Okay, it's a database engine. But internally, this engine has been divided into two engines. One is relational engine, one is storage engine. Your database engine is again divided into two engines internally, not externally, internally. Okay, one is relational engine, one is a storage engine. So you will get one doubt how it is authenticating Subbu. Okay, there is a concept called connection string, sir. There is a concept called connection string. Let me present you one thing, sir. Let me bring you one thing. Yeah, this is how they will pass the connection strings in technically speaking. It's a little high level, but technically speaking, we will call it as a connection string. See, they will pass the server name, they will pass the port number, they will pass the database name, and they will pass their username, they will pass the port password. Okay, they will pass the connection string. Okay, or they will provide the connection string for the reporting services or analysis services somewhere. Definitely, they need to provide the connection string, sir. Connection string is very important. So instance name, port number, to which database they are trying to connect, and what user they are going to use, what password they are going to use. This is very important. There are other stuff also. We'll talk in the advanced level all these concepts when we are talking always on availability group. I will talk more about this. So once they send the request, it is from the operating system it is treating this entire query as a network packets and going to the SQL server, and first it is trying to connect to the SQL server. Before it connect, it is doing lot many things, sir. Okay, so as well, who asked someone, Kamal, right? Yeah, you asked, right? There are a lot of things are happening in the background, like NTLM authentication, Kerberos authentications. There are lots of things. Okay, I'm not talking all this stuff right away. You will go mad. Okay, sorry, not you. We will go mad. Okay, I'm taking back. So we will talk in advanced levels, sir, how this authentication is happening. Okay, because authentication is very important. Means, see, no, everyone can connect to the SQL server, so then the hackers can easily connect to the SQL server. They can hack the system easily. So we need to protect our connections. How you are going to protect our connections? There are many things we are not discussing right away. Okay, we are discussing only a base level of network protocol. Okay, when you are trying to perform certain things, your complete session has been is encrypted in the form of packets. Okay, it will use any one of the protocol, and it is trying to connect to the engine. When it connect to the engine, there are two things again: relational engine, storage engine. Relational engine, storage engine. In the relational engine, it is just processing your query. It is not storing any data. Again, I'm telling, in the entire relational engine, it is just processing your query. Your transaction, it is processing, sir. It is just processing your data. What it is processing, Subbu? Okay, you will get one doubt. What it is processing? Okay, what it is processing means, first it will check. First, when you go to the relational engine, once it authenticates to the SQL server, Once it got authenticated to the SQL Server, your username is valid, your password is valid, your server name, your port number, everything is perfect, sir. Once it authenticated to the SQL Server, it will go to the command parser. First, it will go to the command parser. In Relational Engine, you are having 3 components. Very, very important. Okay. In Relational Engine, there are again 3 sub-components. One is command parser, query optimizer, query executor. Query command parser, query optimizer, query executor. See, in command parser, what it exactly it is doing means, first it is checking the syntax checks. First, it will do the syntax checks. Means while you are running the query, for example, okay, when you run this query, so see, incorrect syntax near from. So first, it is doing the syntax checks. First, it will do the syntax checks. Command parser, what exactly it will do means, whatever the request you are sending, whether that request is properly properly designed in terms of syntax. In terms of syntax, it properly designed. So okay, fine. Once it is done, okay, once it is done, see, there is a concept called parser. See, here you will see the parser. If you just simply run this one, okay, command completed successfully, means your query has been parsed successfully, means your syntax is a valid. Okay, your syntax is a valid. Okay, first it will check the syntax checks. Oh, our job is done, Subbu? No. It need to check the semantic checks also. It need to check the semantic checks. What do you mean by semantic checks, Subbu? Means, see, you are performing select star from sales order details. Okay, whether this table is available in the database. Okay, whether this table is available in the database, in this database. Okay, whether this table is available. For example, I am going for columns. Okay, for example, I am reading some columns. Okay, I am reading some columns. Okay, for example, this column is available in this table. This column is available in this table. Whether this table is available in this database. Okay, first this object is available in the database. Next, these columns are available in this table. So it will validate everything. Okay, once your syntax is done, it is preparing the semantic checks. It will check the semantic checks. What do you mean by semantic check? Means whether this object is available, whether this column is available. Okay, then it will do all the semantic checks. Once it passed the semantic checks, once it passed the syntax checks, next, see, this is high level script, sir. You can understand, but SQL can't understand. See, always whatever you are passing, it's a high level language. Either it can be Java, C, C++, whatever technologies are. Whatever we are passing, those are high level languages which your Java can understand, SQL can understand, C not understand, C++ cannot understand. Those are high levels. We can't understand. Now what it will do is, it will convert this high level to low level language. Nothing but middle level language where SQL can understand. Where SQL can understand in the command parser return. So first what it is doing, it is checking the syntax. Next it is checking the semantic. Now it is converting this into high level to low level language, nothing but middle level language where SQL can understand. Where SQL can understand. Now, once it is done, now it will start preparing the tree. It will start preparing the tree, sir. Tree. Okay, in simple terms, it will start preparing the tree, a query tree. Query tree. What do you mean by query tree, Subbu? Means, it's little high level, sir. It's tough to understand now. Okay, nothing but whenever you go this one, if you go for, okay, so let me start. Okay, let's add order by 9 to Okay. Yes, sir. Okay, let's do, sir. Okay, see, it prepare one query tree. Okay, it prepare one query tree based on your select, based on your query, sir. We don't know how complex. See, this is very small query which contains only the table name. I am reading entire table and I am just ordering the data. Means whatever the data I got it, I am just ordering the data. Only two operations you are doing. Apart from nothing else you are doing, sir. Okay, based on your table details, based on your column details. See, in the select statement itself, you can use from class, order by class, okay, where class, okay, group by class, okay, group by, and having class, okay, join conditions, joins, subqueries. We can do much more things in the select statement. Okay, we don't know how complex my query is. We don't know how complex my query is. So based on your complexity, okay, what SQL Server is doing, SQL Server is going to prepare a tree for your query. For your query, it is preparing the tree, query tree. Technically, you should call it as a query tree. What tables, what columns, what join conditions, what subqueries. So it is converting your query into the form of query tree. It is converting entire your query in the form of query tree. Once your query tree has been prepared, okay, prepared. Now next what it will do, right? For your query tree, is there any plan? For your query tree, is there any plan is available in the plan cache? This is storage engine. Okay. Please, sir, try to understand. Don't think too much. Please don't think too much. You already getting too much. Don't think too much. You will get definitely confused. We'll talk in depth in the advanced level. Okay. I will run the queries. I will show you the execution plans. We'll talk more about this execution plan operators. We'll go deeper, sir. Okay. Like thin line, thick line. What is the sort operator? Parallelism. What is compute scalar? What is cluster index? We'll talk all this stuff in the advanced level when we are talking query tuning. Now, once your query tree is prepared, if your command parser will go to the storage engine, your storage engine. Okay, in the storage engine, these are all storage engines. In the storage engine, there is a plan cache. Plan. See, whenever you are planning something like a vacation or a function, you will plan for that, right? 10 days before, 1 month before, you will plan everything. Once whatever the plan you prepared, you will save somewhere, right? Like say SQL Server will also, not SQL Server, sir, majority of the database engine, they will prepare the plans. That plan is storing somewhere. Where it is storing? In the storage engine, in the buffer, in the RAM. It is storing in the cache. In the cache it is storing. Now this query will go to the plan cache and try to get that in details. For this query tree, is there any plan? Oh, there is no plan because you are triggering first time. When you are triggering first time, definitely there won't be no plan, sir. There won't be no plan. Now what it will do, this query tree will move into the query optimizer. That query tree, internally it will move to the query optimizer, because for that query tree there is no plan. It will go to the optimizer. Okay, now this part you are clear or not, sir? Everyone? Yes? No?
Yes,
What
so,
is command
so
parser is
clear.
doing? Command parser, first it will check the syntax, next it will check the semantic, then it will bind the request, bind your entire query in the form of query tree. Now once it prepared the query tree, it will go to the plan cache and it will verify any plan is available. If there is a plan, it will use the same plan, sir. If not, it will go to the optimizer. Okay, enter your database engine. Optimizer is the heart. Okay, optimizer is heart. I am just discussing only 5 minutes here, sir. Okay, when we go for advanced level, 4 to 5 hours we'll discuss about the optimizer. Now see how criticality optimizer is placing. Optimizer is entire heart for your database engine. because optimizer is preparing the plan for us basically. Okay, basically optimizer is preparing the plan based on your query tree. Then optimizer will start preparing the plan. So in a simple layman terms, now you need to understand, right? Optimizer prepares the plan based on the two. One is the selectivity, one is the cost. Only remember these two terminologies, sir, as of now. Okay, I will show you practically what is the cost, what is the selectivity. I will show practically what is the cost, what is the selectivity. So your query optimizer will prepare the execution plan. So technically speaking, this will called as a execution plan for your query. This is the plan it got prepared. Okay, this many operator, this is the cost of the operator and overall the cost of the query. So it will estimate, your optimizer will estimate and it will prepare the one plan. See, you also, right? So for example, take a generic terminology, sir. Assume for your baby, you are planning for the birthday function, first birthday function, little grandly. Your father will, your mom, you will have a discussion and you will estimate, okay, how many people we are calling, how many people can come to the function. Okay, for example, roughly you are planning that 400 to 500 people will come for the birthday function. Then you will start preparing the dishes. Correct? Yes or no? You will estimate, sir. We don't know. See, no one can guess. We will estimate like same thing. Optimizer will also estimate based on the is data. See, optimizer contains the data, not physical data, logical data. See, this is two things very important. Your physical data, nowhere your relational engine contains the physical data, logical data, information. It knows the information, sir. Optimizer knows the information. Oh, this table sales order details contains, okay, this many records. It knows the information because we are updating the data. In the backend, we are updating the data to the optimizer. Okay, so optimizer knows that, okay, this table contains this much of data. Now what it will do, for example, it contains 500 records. Optimizer knows that this table contains 500 records. Now what optimizer will do? Optimizer will start preparing the plan for 500 peoples. Okay, it will allocate the memory, it will allocate the IO, it will allocate the CPU, it will start allocating the resources to this 500 records. But when the problem will start means when it go to the runtime, okay, when it go to the runtime, the concept has been changed. Okay, now 1000 records come into the picture when it go to the runtime. See, before function you estimated 500 people and you started preparing the dishes for 500 people. Once the function started, now the people has been increasing. Now 500 people become 600 people, 600 people become 700 people, 700 become 800 people. Now finally 1000 people it become. Now whatever the dishes you prepared, that is sufficient? No, right? Everyone, see.
No.
Then what will happen? You will struggle a lot now to serve that 500 resources, whatever you prepared to the 1000 people. You will face a lot of difficulty. Like same, whatever the resources allocated to this query, okay, now that is not sufficient because when it go to the runtime, the value has been changed. Why, Subbu, the value has been changed means you not updated to the optimizer. See, we need to update the data to the optimizer. Hey, I am having this much data. I'm having this much data. If you're not updating to the optimizer, optimizer will estimate whatever the data is available at the optimizer level. Based on that, it will prepare the plan and it will provide the plan. So that is a small thing, sir. So to the new people who are starting the journey, there is a concept called update statistics. Update statistics. So this is very powerful concept, sir. This is very powerful activity, powerful concept. So this, if you're not performing regularly, your optimizer is not updating regularly. You means you are not updating optimizer regularly. you need to update the statistics regularly so that optimizer knows accurate data, accurate information. If you're not doing this one, your optimizer is in the back end only. For example, today there are 1,000 records. You updated the statistics. Okay, optimizer knows 1,000 records. Optimizer will prepare the plan for 1,000 records. Now tomorrow you perform 1 lakh records. Okay, but you not updated the statistics to the optimizer. From optimizer point of view, only 1,000 records. But actually, how many records are there in the table? How many records are there in the table? 1 lakh records. So now the problem started. When it go to the runtime only, the problem will start. Not in the processing time. When your query processing time, you won't face any challenge, sir. When the query started executing only, the problem will start. Because then when the query executed, then it realized, okay, I am not having 1,000 records, I'm having more record to process, more records to render. Now, whatever the resources it allocated, your optimizer allocated to the query, that is not sufficient. Now, definitely your query will run slow. Every time this is the issue, no. But this is also one issue. Getting my point? If you're not updating the statistic to the optimizer, definitely your optimizer will not prepare the best plan. Got it? No? Yes? Sir, if you're not understanding,
Subbu,
raise your voice. Yes.
No, Subbu, we are getting, but Subbu, that case we need to the every time we run to update the state after the run the query, or we can wait from the
We'll talk, sir.
when
That
the
we'll talk. No, that's what I told you, right? Let's stick with only this one. Don't go for statistics. We'll have a separate session, practical session.
No,
Okay.
I'm just understanding. Suppose
See,
I have
update
now
statistics is a regular basis. Either you will go for weekly basis, or you will go for alternative basis, or you will go for monthly basis. Because how you are changing, how your data is changing, until unless you should talk to your application team, right? Yes or no? See, if you go and talk to your application team, they will let you know, okay, these many frequently will change the data. Okay, oh, this is how you are frequently changing, then better we'll create every 3 days once we'll update the statistics to the optimizer, so that optimizer who can prepare the best plan. Can I run daily basis? Means if your database is very smaller, yes sir, okay, fine, but your database is massive. If you're running update statistics daily basis, it may impact the performance also. Okay, so there is lot of concepts. There are auto update statistics, auto create statistics. There are a lot. Don't deep dive to the update statistics as of now. What you need to understand high level. Okay, optimizer is preparing the plan. Okay, plan based on the statistics available. Based on the statistics available. Okay. Okay, that is a one point you need to remember. Okay, fine. Whatever the statistics information optimizer knows, based on the statistics, it will start preparing the plan. How it is preparing the plan? Based on two things. One is the cost base, one is the selectivity base. One is the selectivity. What do you mean by selectivity? How much of data you are processing? Means how much data of you are reading the data, you are processing the data. So selectivity. And one more is cost. Cost is also very important. It's a see. For us, cost is money. For human beings, cost is money. For systems, cost is in the terms of CPU, in terms of memory, in terms of IO. So this is a cost. Okay, cost. So based on your cost, based on your selectivity, your optimizer is preparing the execution plan based on the statistics available. Based on the statistics available, your optimizer will estimate a plan. Okay, this is the plan which will suits for your query. But that will good or bad, when it go to the runtime only, will come to know, sir. I getting my point, everyone? No? Yes?
Yes, Subbu.
Only think this much, sir. Don't go deeper. Sorry. Okay. Don't go deeper.
No, Subbu, it's the
There are a
right.
lot of things.
Nice. Subbu, in the optimizer, that time same the phase 1, phase 2, phase 3 generate trivial plan or other phase will be generated. Same time it will be. And then
Yes, sir. It will prepare. It will see internally. It will prepare some plans and it will choose the best plan. Finally, it will choose one best plan. The cost is very important, sir. Cost is very important. Selectivity is also very important. Both are very important for us. Yep. Someone is
So
asking.
cost
Yes,
mostly we are taking to the IO or CPU memory, all the three combination, or just we taking care of the CPU memory or IO.
see, every resource is very important. Out of that, IO is very important, sir. Input output is
Okay.
more powerful. When you see CPU,
Yes.
memory, storage. See, you can increase the CPU. You can increase
Yes.
the memory, but you can't
Yes.
increase IOs, right? Once you purchase
Yes.
the storage.
Yeah, Subbu.
See, once you purchase the storage, you can't increase the IOPS, inputs, outputs. When we are talking about the storage, I will talk about what is IOPS, what is throughput. We'll talk that much level, sir.
Okay.
Yeah. Questions? Everyone? No?
So,
Yes? Yes.
where can we see whether update stats is
Yeah,
running?
that's what, sir. We'll talk. We'll talk.
Okay.
Okay. No worries.
Okay.
No worries. All the stuff. Okay. As of now,
Okay.
no worries. Just understand high level hierarchy only. Everything I told you, right, will go practical demo. I will show you practically what you mean by syntax checks, what you mean by semantic checks. I will show you practical, sir. I will show statistics also, because 2 days we are spending on statistics. Optimizer. Then how much knowledge you will definitely gain, sir. Okay. What do you mean by selectivity? What do you mean by cost? Okay. How the statistics are working? What sort of statistics it will create? There are much more, sir. I can't explain in just 2 to 3 minutes. It's very tough to explain. So as of now, high level, okay, what you should understand is two things are very important. Two things. One is command parser. Hey, come on. Oh, it's not. Oh, it's not this one. Okay, 1 second. Okay. See, basically, command parser, what it is doing, it is first checking the syntax. Is it clear, everyone? Is it clear, everyone? I'm raising
Yes.
everyone, sir. Unmute and tell. It is just checking syntax. Fine.
Yes.
Yes.
Next, it is
Yes.
doing what it is doing? Semantic checks. What do you mean by
Semantic check.
semantic checks? For our
Binding
understanding
the
purpose.
object.
No. Semantic checks is whether this object is available. This column is available. Okay, whatever the
Okay.
column you are trying to read, whatever the column you are going to process, whatever the table you are going to process, whether the table is available. Okay, whether that view is available, whether that SP is available, whether that function is available. Okay, and the columns is available, whatever you are writing in the order way or where class, where sales or something, whether these are available. So this is what it is checking. Okay, semantic checks is whether that object is available, column is available. That much level it will go and check, sir. Once it got everything, okay, your syntax is fine, your whatever you are reading is fine, means objects are there, columns are there, everything is there. Okay, now it will start binding the request, preparing the query tree, like converting the language to high level to low level language. It is preparing the tree. Once your query tree has been prepared, now next what it is doing, it will straight away go to the execution plan. Sorry, my bad. Plan cache to verify any plan is available for this query tree. See, it is straight away coming. Your command parcel is coming to the plan cache, whether any plan is available or not. Okay, plan is available means it will use the same plan. It will see. We also write, sir. Whenever you are planning for a trip, we will make one plan. We will also prepare multiple plans. So, for example, I wanted to travel to within my region. So I can have multiple plans, right? I can use a bike, I can use my car, I can use my local transport like buses. Okay, I can borrow the cab also based on my budget, based on the people. I can based on the days. I can plan everything, where I need to stay, where I need to what places I need to watch. Everything I will plan, and I will also plan like one or two plans, alternative plans, in case if this plan goes wrong. I can have one more plan also. Like same SQL Server is also doing same things. Okay. Now whatever the plan is prepared, you are storing in your brain or you are writing somewhere. Like same, SQL Server is also creating the plan and placed in the temporary in the cache, nothing but in the RAM. Nothing but in the RAM. It is placing temporary in the RAM. Okay. Now this B tree will go and find, oh, plan is available. Oh, plan is available. Let's directly jump into the executor. There is no concept called optimizer. That time there is no optimizer. It won't work with the optimizer. Directly it will go to the executor. Executor will start executing the query. Because in entire relational engine, there is no data. Yes, your query is processing stage by stage. It is processing, sir. Assume if there is no plan, your optimizer will prepare the execution plan. Once it prepared the execution plan, it will pass that plan to the executor. Now executor will start executing that plan, and it will also store in the plan cache. Okay, whatever the plan it is preparing, it will store. Finally, that plan will be stored. Final plan will be stored in the plan caches, or not all plans. Okay. Now executor will execute the data, whatever you are requesting. Either you are inserting, updating, deleting, creating, altering, dropping, truncating, whatever you are doing, it will start executing. In entire relational engine, there is no data. In entire relational engine, there is no data. Now what it will do? Your relational engine will send request to the storage engine. Will send request to the storage engine with the help of ODBC drivers. ODBC drivers. See, every system, sir. Every system you are having ODBC. Whenever you install SQL Server, by default you are getting ODBC drivers. ODBC drivers. So using this ODBC drivers, your relational engine and storage engine are communicating internally. Internally, your relational engine, storage engine are communicating with help of ODBC driver internally. Internally, it is communicating. Now, when you go to the storage engine, see, enter your storage engine also having the logical data. See, best example I can give, sir. If you go to the bank, okay, every bank they're having main locker, right? Everyone, there will be main locker, and you are having the accountant where you will go to that accountant desk and you will ask, I need to deposit, I need to withdraw, and he is also maintaining some caching. Okay, once he logged in the morning, he will go to the main locker, get some amount and keep in the cache. And whatever the cache is available, he's processing that amount only in the whole day. In case that got completed, again he will go to the main locker, get the data. Correct? Yes, don't tell no, sir. This is the banking. Everyone, at least once in your career, you will visit it. Correct?
Yeah, exactly.
Same thing, sir. Same thing. What it is happening means, enter your storage engine is nothing but your temporary. This is temporary. There is a physical storage. Disk is your physical. RAM is your logical. Okay, RAM is your logical. Enter your data is processing in the RAM, nothing but in the cache. RAM is like a cache, sir. Because RAM is much faster than disk. RAM is much faster than disk. RAM, you will calculate in the nanoseconds. Disk, you will calculate in the milliseconds. Okay, nanoseconds are much faster than milliseconds. So RAM is, you will calculate in the nanoseconds. Disk, you will calculate in the milliseconds. Basically, when you are calculating the performance, you will calculate in the milliseconds. So what it will do internally? Yes, tomorrow we'll talk about storage engine. Okay, we'll talk storage engine, sir. As of now, tomorrow we'll talk about storage architecture. Storage engine, storage architecture. Storage engine we are discussing today itself. Okay, storage architecture is something different, sir. Physically, how your data is storing is storage architecture. How storage engine is performing is something different. Now, your executor will request to the access method with the help of ODBC drivers in the background. Okay, now access method is also not having data. So access method contains multiple APIs, application programming interface. Okay, what do you mean by APIs? application programming interface, lots of application programming interface, where access method can understand whether it is a select or whether it is a non-select. Because see, select is nothing but reading the data. Okay, reading the data. No, non-select means it can be anything, sir. Non-select is nothing but inserting, updating, deleting, dropping, truncating, okay, creating, altering, renaming. Okay, these are all granting. These are all non-select statements. These are all non-select statements. So it need to understand, right, what you are doing. So these many operations you can perform in the system. Every time I will read the data, no, you can insert, update, delete, drop, truncate, drop, much more stuff you will do. That need to be understand. What is your request? It need to understand. So access method contains multiple APIs which it can understand what sort of request you are passing, what sort of request you are requesting for us. Now, based on that, okay, your access method is also not having data. Okay, access method can understand your request. Now, access method will send request to the, this is your buffer manager. Buffer manager. Nothing but RAM, sir. RAM. Don't get confused. Memory. RAM. Buffer manager. Okay. Buffer manager. Within the buffer manager, there will be buffer pools. So what it is doing? It is creating the buffer pools. Buffer pools. Within the buffer pools, there are having caches like a data cache, plan cache, log cache, log cache, logs, log cache, plan cache, data cache. There are a lot of caches out there. Out of this, these are the most popular caches which we'll remember. Data cache, plan cache, log cache. So there are a lot of caches are available internally. We will talk about these caches also when we are talking about the memory troubleshoot, sir. When we go, see, each and every component will go a little deeper when we go for that concept. Okay, when we are discussing about the execution plan, we'll talk about plan cache. When we are discussing about memory, we'll talk about the data cache. Okay, when we are talking about the statistics, we'll go for optimizer. Rest of the components, okay, sir, we are not focusing that much, and that is okay. Just processing the data. Apart from nothing else, they are doing. So data cache is very important. Plan cache is very important. Optimizer is very important. We'll go practical and we'll talk practical only. Majority stuff. Now, in the buffer manager, there are buffer pools. In the buffer pool, there is a plan cache, data cache, plan cache, log caches. Now, for example, if you are reading the data, examples are you are reading the data. Now, first it will go to the access method. Access method sends request to the buffer manager. Buffer manager will send request to the buffer pool. Buffer pool will send a request to the data cache. Now, for this select statement, select star from EMP. For this employee details, any data is available in the cache. For example, you are executing first time. Definitely there is no cache. There won't be no cache, sir, because when you go to the banking sector at the evening, everything they will kept in the locker only, main locker. So in the caches, it is empty. Nothing is there. Now what it will do? Okay, there is no data right in the cache for this select statement. Now it will go to the main database, nothing but disk. It will go to the disk, get the data, place one copy in the cache, and sends the data to the requester. That's it, sir. That is what it is doing. Okay. Whenever you are executing first time, there is no data relevant to this employee table. Now it will go to the data cache. It will verify any data is available. Oh, currently there is no data. Now it will go to the disk, get the data, and place one copy in the cache and sends the data to the user. Sends data to the user, then user can see the data. No? Yes? Understood? Not understood, everyone?
Yes, Subbu, I understand.
Just
Subbu,
high level, sir. I am not going. Okay. Then you will ask one doubt, the experienced people. Subbu, I am having 10 GB of RAM. Okay. My table size is 1 GB. Okay. Then how it can fit in the memory, right? Correct? Yes or no?
Yeah, Subbu, but we have asking one more thing here
Yeah.
regarding RAM or memory, other things. Subbu, suppose my the data first time data will be query will be executing. So after the query executor, it will going to access method. On access method, go to the buffer manager, then buffer manager to buffer pool, then data cache. Is that right?
Because see, every engine, okay, not only SQL, sir. If you go to the any engine, is having its own memory, sir. It's having its own memory. Okay, memory management. So all the engines, like if you go for Oracle, Postgres, see, that's what, sir, I mean to say. Whatever I told, I explained same thing. You will see even when you go for Oracle also, same concept. But whenever you see this architecture, okay, it's a lightweight. Okay, this is detail. I explain in the detail only, step by step, what it is doing, everything. Okay, it is checking semantic, syntax, it's semantic, preparing the tree, the plan. Once the plan is prepared, then it will go to the access method. It will go to the data cache. It will find when any data is available. If not, it will get the data and it will paste one copy and it will send to the requester. This is the high level. And this is what only you need to remember, sir. Okay. When you are explaining to the interviewer also, same level you need to explain. Don't go deeper, because as a best interviewer, when you are delivering to the interviewer, when someone asks about SQL architecture, you need to explain short and sweet architecture, sir. So you need to plan. I need to explain for 1 to 2 minutes, enough with the good content. So don't go deeper and like elaborate for 5 minutes, 10 minutes, so that your 30-minute span will be reduced, so that you can avoid other questions. I know you are smarter. Okay, we are smarter, but interview is also smarter, sir. Okay, explain short and sweet architecture if someone is asking. So you no need to explain protocol layer, all this stuff. Start from like a SQL Server follows client server architecture. When we are processing any request, it will process from the network layer to the DB engine. In the DB engine, there are two engines like Relational Engine, storage engine. In the Relational Engine, we are having sub components like command parser, query optimizer, query executor. First, the command parser will check the syntaxes, then check the semantic checks, and it will bind the request and prepare the query tree. And it will go to the plan cache, verify any plan is available. If not, it will go to the optimizer. Then optimizer will start preparing the plan based on the statistics available, and it will mainly prepare with the selectivity with the cost base. Once the plan is prepared, then our executor will choose the best plan based on plan prepared by the optimizer. Now executor will send a request to the access method with the help of ODBC driver in the background. Access method can understand what sort of request it is, a select statement, it is a not select statement. Okay, see, I mean to say it will take a lot of time to explain like this, but if you are explaining like this, you are super good, sir. So consolidate everything, okay, and prepare one a neat architecture explanation. I hope you are getting my point, everyone. So no need to tell all this stuff to the interviewer. They will definitely confuse, and there may be possibility chance also your interview will be diverted. Okay, see, always we are little smarter when you are attending interviews, when you are going for interviews, sir. While whatever explanation you are doing, that should not raise one more question. Okay, not okay, everyone. Whatever you are telling, if he caught somewhere and if you start raising a question from there, then if you're good at technical, okay, sir. If not, then definitely will caught. So smarter explanation is okay, but understanding, you should understand everything, sir. Okay. Got it. So you no need to tell to the interviewer like a buffer manager, buffer pool. Cache is a cache. That's it, sir. Okay. Buffer manager, buffer pools, all the stuff. No need to tell. Interviewers already know about SQL. So there are a lot of caches in there, like a data cache, plan cache, log cache, log cache. So you need to tell whether data is available in the cache. If yes, it will get the data from here itself. If not, it will go and get the data and send to the request. That's it about SQL architecture. I hope I explained easily only. The people who are first time listening, how you felt, sir? Easy, tough? No, yes.
It's
Anush,
easy to understand. Yeah. It's very wonderful.
Anush.
It is about night session, Subbu. It's understandable.
Yes.
Yeah.
It's also expensive.
Yeah. Thank you. Okay, the people, I don't know many people who are freshers, who are laterals. Okay, you should understand, ma'am. Don't think too much as of now, ma'am. Everyone, for example, take Anusha, Priyanka. Priyanka is already experienced. You can understand. For example, take Anusha. Don't think too much when you go for architecture. Short and sweet answers always. Okay, this is best. Anyhow, we will talk everything practical. You will become strong. Okay, we will talk everything
Subbu,
practical. You will strong.
last time I'm going to take an interview in SAP. It will take I have done the interview, but they take interview almost 30 minutes to the architecture, deep and deep and deep and deep SQL architecture. That whole interview take a 2 and 5 hour.
Yeah. So what question they will ask you? I will tell you, sir. Okay. See, this is about simple select statement. Okay. But when you are processing modifications like inserts, update, deletes, that is the one question they will ask. They will ask one more question like how ESPs means when you are running a stored proc. They are expecting from the compile time. There is a run time. There is a compile time. Okay. Compile, recompile. The plan will be SPs will be recompile every time. Okay, when you are using recompile, so they're expecting little difference. That's the one thing I'm telling. Our architecture is not done. Our explanation is not done. There are still 4 to 5 sessions are still pending. I am just telling high level only. Okay, we'll talk each and every category in deeper when we go for advanced level. Again, I will come back, sir. I will only let you know, hey, you remember that day I will talk only 5 to 10 minutes. Now we are talking deeper. Okay, that time you need to understand. Okay, in the day one, Subbu told that architecture just for 5 minutes. He promised that he will deliver in the advanced level. You will itself understand, sir. I will stress in that respect to concept. Hey, you remember that day we'll talk only 2 to 3 minutes. Now see how much time you are spending on this concept, because cache is very important. Plan cache is very important. Optimizer is very important. SQL command, SQL CMD processor is also very important. We are thinking that this is not important. This is very important. Access method, okay. We are not focusing that much. Executor is just executing, sir. Access method is just processing the data. So we don't need to think much about. But buffer manager, see, buffer manager is very important, but rather than focusing on buffer manager is nothing but cache, sir. So in entire cache, one of the most culprit is this data cache only. Okay, in entire cache, see, to tell you, select star from sys dot em underscore os underscore memory underscore plus. Okay, clucks. Okay, so we are having almost 405 clucks. If I wanted to get more information how the memory is controlling in the background, clucks will play a major role. Out of entire this clucks, order by pages KB. Okay,
Yes.
descending. Okay, yes, this one. This is nothing but your data cache. SQL buffer pool clock is nothing but your data cache. This is the most culprit clock in the entire memory, sir. So that's what I showed you, right? I will show you practical. See, now what do you mean by data cache, sir? Subbu, you are saying data cache, data cache, data cache, data cache. What do you mean by data cache? It's nothing but a clock in the background. What is a clock? Memory clock, SQL buffer pool. This is the clock is nothing but your cache, sir, data cache. And this is the most consumer every time. Okay, how the data is consuming also, I will show you, sir. Okay, when we are dealing with the memory. Kamal, I hope you are getting my point, what I want to convey. So
Yeah,
I will
Subbu.
show you step by step what you need to look, where you need to look, where you need to go, and what information. See, always information is very important. When you are troubleshooting something, you need to get the information, sir. Okay, so that information I will pass you. Not now, okay, but when we go for advanced level, because first
Yes.
you need to prepare this one at least. Okay, oh, in terms of architecture, we are having a protocol layer, we are having a relational engine, storage engine. In relational engine, we are having command parser, query optimizer, query executor. In the storage engine, we are having access method, and we are having lot of caches like a data cache, plan cache, log cache. Okay, so all these are very important, and transaction manager is also very important. Okay, see, log manager, plan cache, data cache. These are all in the cache only. We haven't discussed about this stuff. We'll talk, sir, when we are talking about log file architecture. Log file architecture. So slowly you will digest everything. Okay, I told you, right? First 2 to 3 days it will be heavy, hectic load only. Okay, massive content will share. Majority of the people are confusing, but I'm trying my best to reduce the content, sir. Okay, to deliver in a proper, meaningful, understanding way. Got it? Yeah, that's it, sir. Today, I will share one notes. Okay, I will share one document, 2 documents, sir. Go and prepare those 2 documents. You will get a simple, basic idea about SQL architecture. Okay, for experienced people, you are already strong, sir. I don't need to share that simple content. But the people who are lateral starting, definitely you already got mad. Okay, to reduce that mad, I am sharing 2 documents. Just open the documents. You will find the SQL Server Architecture in a briefly. Okay, that is a brief content you can easily deliver. Okay, got it?
Subbu,
Yes.
this content will be sharing from the mail, or is there in this chat group, or
As of
where
now
is
in the
it?
WhatsApp, sir. As of now in the WhatsApp, in the from December onwards, we'll go to the website. I'm working with the blogs. Okay, so we will go into the website. Whatever we shared so far, that will be updated in the website, our blogs. Okay,
Okay.
so you no need to miss nothing. Everything will be there only, and we'll
Okay,
keep
Subbu.
something in the video description also, so you can
Sure.
find the video description.
Sure, Subbu. Thank you, Subbu. Nice session.
Yeah, thank you. See you tomorrow, sir.
That was rough, but thank you.
Yeah, thank you.